doesn't allow access from anyone besides system. And directory B doesn't allow access from anybody besides system. But C allows access to everyone to read, and there's a file in there for read. Now the idea, you think, well, maybe the person shouldn't be able to read it, right? Because the top level directories have this permission set. The hierarchy is set to deny, right? But when you enable bypass reverse checking, that's turned off. So if I create a file in the bottom directory on SMB or registry or anything, it's allowed by everyone. That whole top hierarchy is ignored. It's been like that since 2003, apparently. You can't even disable this check in Vista, Windows 7, or 2008. It'll just break. Well, you can disable it, but if you log in, all your services will fail and shut down. But it's there. So it's an interesting thing to know about, especially for IT security in general. Continuing. So another comment. At this point, you believe it may not be a security problem because of inheritance. So the concept of inheritance is when you have an object with permissions. Any child object of that, say it's a directory that has admin privileges, right? And any file created in that will inherit the permissions of the parent. The problem is when a directory is created secure at the top, say users for a large company, and you want to add a directory of permission for anyone to write to a directory, you have to turn off the inheritance or remove them. So you have to be able to edit the changes. And by doing that, you no longer have inheritance. So by saying that, it goes against the principle of bypass reverse checking and the principle of creating an account. Does that make sense? You have to turn this off to change the privileges. And when you turn it off, it's off. And bypass reverse checking is there now. So there's this kind of untalked about issue in NT of access control. That's kind of been assumed for a long time. But if you go and check that and you work with your own file system, you'll see that when these things are in place, it causes major issues. So you want to be very cautious of that, I should say. So as I mentioned, object creators often add explicit permissions to enable IPC. It's not like a file system with inheritance. When I create an object, I explicitly define who should read or write to it, right? Because that's an IPC. Usually, quite often, you're going to define permissions for that. Now, another thing that's interesting is while the object manager directory shares a lot of NT file system characteristics, there's no inheritance actually built into it at all. We can't find it. I've double-checked this in the last several weeks, reverse engineering everything in the object manager. I haven't found anything with inheritance, any support for it. So that's out the window too. So you have bypass reverse checking, not checking directory layers, and you have no inheritance. So for the most part, a lot of your access control is out the window. Anyways, you're creating it because it looks important. Which is a shock. This is all there. Deliberated religiously with my coworkers over this to prove all the theories and thoughts and created examples, which I'll do one for every single big claim that I make. So for namespace traversal. So in this demo, we're going to demonstrate that you can walk across a namespace boundary and access other users' objects with the way it's built, just the way it's built in the object manager. So I have a VM setup, VMware image running Windows Vista, currently patched, updated. Let's see here. And these are not zero-day issues. They're bugs in the operating system, but I'm not releasing something that I hope people can maliciously use, or hope they cannot. That'd be a Freudian slip. That'd be bad if that was. Okay. So we're going to create a local section, just a share. I'm going to call it test. It's just going to read data from this memory and write to the screen, so I can, when I'm writing to it and toying with you, I can see. And what we're going to do is go into our object manager here, and we should see in session 1 or 2, let's see, base name objects. We can go down to test. It's not there. I think I'm actually, as admin, I can see all the directories, obviously. Should have a test in here. There it is. So what we're going to do is emulate an object with permission that's low down the directory in someone else's session, right? Say cool find search engine or Google toolbar or something, or Ask toolbar, one of these things, right? Creates an object in your session, and you're assuming that the session environment around that will protect that object from another user. So let's remove this. This is an old account. It's stale. We're going to add everyone. See that barely. Okay. I'm going to add write to it, read. That's it. So now I'm going to switch over to my limited user, and I'll show you the privileges of that user. A goldfish, he's trapped in his little goldfish bowl, you know. I'm trying to get higher privileges to get out of it. Okay. I haven't had a lot of sleep. All right, so sections app is a simple tool I wrote. So I'm going to pass in, let's back up. We'll do sessions. Was it 2 or 3? 3. I'm glad I got you guys here. And then test. Oh, basically I'm object supposed to. Okay. And test. We're just going to zap, like, 5,000, 3,000 bytes. There we go. Let's do a little more, because that buffer I think is actually 2,000. All right. And also, who am I? I should run that. I don't have any special privileges here. I've got, let's see, bypass reverse checking. It's enabled by default, all accounts. Interactive group, authenticated users, this organization. I am a limited account. No admin privileges whatsoever, basic account. Okay. And now we'll switch back over. So it's copying, string copying data into buffer, mem copying. So I've corrupted that across session namespaces. Now, the reason this worked is because the APIs will limit you to only your local object. But that, when I called that section zapping, it just called directly into an NT function, right? Passing it directly into the kernel through an interrupt without checking all those parameters. So I can access direct pass in the object manager. So here's an example. It's still breaking a couple times. All right. So what does that mean? Any application that creates an insecure object can be accessed. If it's accessible by everyone, anyone in another session namespace or a compromised process of any degree service can traverse over and read and write to that. So I ran some tests and some OEM software, and none of the advisors or anything are ready today, but there's quite a few products out there affected, all right, by this issue that allow an automated escalation of privilege to administrator. Yeah, OEM stuff with Crapper is just a nightmare because you have projects that are shipped out, hardly tested, but they may not even have source code coming from from outsourcing. It's just passed on, shipped in. Still these problems with rootkits and some of these devices and a lot of that. It's often the same kind of Crapper idea. You have the software coming in, no one checks it out, and they put it on a machine, right? And when OEM's involved, it's a lot of money, right? So you get this kind of issue. You have to be careful with it. Now, object security controls. There's ways to set an object security, which are the DACL, the list of what are called ACE entries. Every account, you put an account in there and an access or deny, and you get a list of those entries, and that's called a DACL, right? Ultimately in Windows. You guys have probably heard that 1,000 times before, but just in case. So you can set these on an object after it's created or when it's existing. Set kernel object security, private object, user, just a type of object, and what you want to set. So, what's interesting about this too, another variation of kind of attacks on objects, is that when you set after it's created, programmatically you don't really see this, but there's a small race condition there between when it's created and when it's changed. So if you create it with a default DACL that's insecure, it allows everyone, and then restrict it, 3 functions later, an attacker can write a tool to probe these objects and then compromise them in that small window, right? That's the same idea of creating a file and a shell script and then gmoding it later. It's all over the place. Yeah, that's always have a small window when you can race in and jump in and take it or override it or whatever you want. In the case of a global namespace, it's a lot more likely an attacker can see these. So objects are governed through security descriptors. As I mentioned before, the DACL is part of the security descriptor. The other things are kind of erroneous and not mainly for this talk, but the owner and grouper, I guess, important too. So, what else? Yeah, so most of the APIs allow you to supply your own SD. Let's say a security attribute or a creation attribute. And if you look closely, it says security descriptor. There's a lot of code out there to create your own. And if you have trouble finding it, I can send it to you too. We can create a security descriptor